Okay, hello students. For today, we are going to look at two questions. Topic 17, page 9, and later on topic 17, page 12 of the topical TYS. So for this first question over here, okay, how do we even start off? Okay, you have to look at the information very carefully. So from here, we are able to see that this is actually a parallel circuit. Okay, so when you look at questions like this, immediately you try to recall what are the special properties of the circuits itself. So for this parallel circuit, we can recall that firstly, the potential difference across each branch is always the same. Secondly, the sum of the currents from each branch, okay, will actually make up the total current for the circuit itself. Okay, so let's look at the information that is given. They tell you that the total effective resistance of the circuit is 0.75 ohms. Okay, they also tell you that the current in the resistor is 3 ampere and the current in resistor Y is 1 ampere. Okay, so with this additional information, okay, and at the start they also mentioned that the EMF is 6 volts. Okay, we should be able to solve the questions. So for part A, the current in battery, if you look at the current in the battery, okay, you need to understand that they are actually not asking for what is inside the battery, but rather, okay, this is actually asking for the total current. Okay, so basically, what is the total current? But if you look at the whole circuit itself, we do not know the resistance of the resistor Z. So with that in mind, we can't solve using the total resistance method. However, okay, we are given this information, which is the total effective resistance of the circuit is 0.75 ohms. So this tells us that when we look at the circuit itself, it is just this circuit, okay, where 0.75 ohms is here, 6 volts EMF is here. So through this new diagram that I've drawn for myself, okay, I can actually easily tell that this is the current I'm looking for, the total current. Okay, so from here, okay, we know that the formula we need to use is V equals to IR. Okay, where I need to find the current means I equals to V over R, which will imply that I have my current equals to 6 divided by 0.75 ohms. Okay, so if you do it correctly, okay, you should be able to get the value of 8 ohms. 8 amperes. Okay, so this is worth 2 marks. So remember, you have to still present your values because of the word, the working because of the word calculates here. Okay, that's why I'm presenting over there. Okay, for part B, find the current in resistor Z. So how do we approach this question? Remember, at the start, we actually mentioned one of the property of the parallel circuit is that the sum of the current in each of the branch, okay, will give us the total current of the circuit. So if I were to call this last branch itself, the current to be I1, okay, and since I have already calculated the total current in the battery, okay, at part A to be 8 amperes, so that would mean that I total will be equals to 3.0 amperes plus 1.0 amperes plus I1. Okay, from the previous answer, we know that the total current is 8 amperes. Okay, so let's work some of these things out. Okay, we get 4.0 amperes plus I1, which means my I1 is actually equals to 4.0 amperes. So that is my answer. Okay. Now, for part C, you are tasked to find the resistance of resistor Z. Okay, there are a few ways to do. Okay, I'm going to explain each individual way. Okay, first method, okay, is that since this is a parallel circuit, okay, and I know my current I1, okay, I actually know that the EMF, the 6 volt here, is actually the potential difference across the resistor Z as well. So, having known this information, V equals to IR, I want to find my resistor, V over I, which is equals to 6 volts divided by the current, which is found in the previous one to be 4.0. Okay, so I will get 3 over 2, which is 1.5 ohms. Okay, no second method. So this gives us the answer as 1.5 ohms. Okay, do remember to present your answer as 2 significant figures or 3 significant figures. Okay, so I hope that this practice for the parallel circuit is sufficient to help you understand the chapter itself. Okay, let's move on. Now we have topic 17, page 12. Okay, and you can see from here that the circuit itself is actually a combination of series in a parallel circuit. Okay, in fact, it's 2 series branches. Okay, so you are asked to calculate the potential difference across the resistor W. So, which means you are looking for the potential difference of this. But based on the question, okay, you are already given that the current flowing through the resistor over here, the W itself is 8.0 times 10 to the power negative 3 amperes. Okay, so with this in mind, if you look carefully, I have my current, I have my resistor. Okay, so V equals to IR is the formula we need to use. Substitute in the values, 8.0 times 10 to the power minus 3 times 900 ohms. Okay, would give me 7.2 volts. Okay, so that's how you get your value. Okay, part B, show that the potential difference across the battery terminals is 9.6 volts. Okay, so working on the same idea from part B, we know that the current flowing through here is the same. Okay, so the current going through the 300 ohms will be the same as the current flowing through the 900 ohms. I'm going to use this. Why? Because if I know the voltage here across the 300 ohm, and I know the voltage across the 900 ohm resistor, then the total EMF, the total potential difference across the whole branch is actually the same as the EMF. So that's the idea that we are working on. Okay, so let's work from that angle. Okay, so now I'm looking for the voltage across the 300 ohm resistor, which will give me 8.0 times 10 to the power minus 3 multiply by 300 ohm for the resistor. Okay, so I have value as 2.4. So now, because the W and X are actually in series, okay, so the total voltage would be 2.4 plus 7.2, which will give us 9.6 volts. Okay, and therefore it should. Okay, next one, part C, calculate the current in resistor Z. So now you need to find the current flowing through here. Okay, But we now know that the EMF is 9.6 volts because based on the answer from part B. Okay, so how do we approach this question again? Look carefully. I'm going to erase off all the things that are not critical at this moment. If you look carefully, okay, we have this last branch over here, okay, where the two resistors are there, 800 ohm and 700 ohm are in series in this particular branch, okay, and knowing that the potential difference across the series circuit, okay, is actually the sum of the individual potential difference in that that whole line of components. Okay, we can actually make use of that, or I can make use of effective resistance of a series circuit. So using the idea of effective resistance in that series circuit itself, okay, shouldn't write V, I should have written R. Okay, R total for that particular line would be 800 ohms plus 700 ohms. Okay, so 800 plus 700 would give us 1500 ohms. Okay, so from here, I know my V equals to IR can be used. Okay, and V is 9.6, so I want to find my current, V over R, okay, which will give us 9.6 volts divided by 1500. Okay, this would give us 6.4 times 10 to the power negative 3 amperes. Okay, and that's how we actually get the value over here. Okay, so in terms of presentation, okay, this is already 2SF. Okay, if you add another 0 behind the 4, you actually get a 3SF answer. Okay, for the SLS, it's very difficult to key in the indices format. Okay, you can key in as this particular value. Okay, so that you can check the answer over there. Okay, with this, we'll end the recording.